Welcome everyone to our third session for our NetBuilders multi-cloud series. I'm Tom Ferranti, SE Manager out of the Northeast US, and joining me today is Joe Yohannan, a Systems Engineer out of the Southeast US. Just a quick recap here. For session 1, we had Doug Gourlay, Fran Lohman, and Fan Yang set the stage for our multi-cloud series and walk you through exactly how Arista's industry-leading software approach enables our customers to build a true enterprise multi-cloud backbone. And then, stepping into session 2, we had Fan Yang again and Vipul Chib build on what you heard during the first session and took you through a deep dive into how you can extend your segmentation strategy to the public cloud as well. As many of you know, the introduction of the public cloud has made consumption of services very easy, but has also challenged the network operational model. So today, we're really going to focus on how Arista enables customers to standardize their operational models with our CloudVision solution. Just to highlight exactly what we're going to cover today, here's a brief agenda. Following the session's introduction, which I'm going through now, I'm going to level set everyone on exactly what Arista's EOS or Extensible Operating System is, as well as CloudVision. Some of you may already know this, but it's a good opportunity for everyone to have a foundational baseline as we go further into the technical solutions during today's session. From there, I'll walk you through a brief recap of our multi-cloud dashboard and CloudVision portal. I won't spend a ton of time here since Fran and Fan already covered this during session 1. We'll look at CloudVision's CloudTracer application and how you can simplify your provisioning approach, develop cookie-cutter configuration templates, which in turn eliminates human error altogether. After that, I'll hand things off to Joe to walk you through CloudVision's topology view, compliance dashboard, and change management workflow, and then we'll wrap up today's session. What you'll hear about throughout today's session really highlights Arista's overall approach to delivering architectural consistency. We believe in keeping things simple, scalable, and enabling the utmost flexibility with our open operating system and APIs. With that strategy, you're able to build that consistent model, leveraging a single binary operating system with Arista's Extensible Operating System, single pane of glass operational model with CloudVision Portal, which can be leveraged across any place in your private or public cloud. Whether it's a small remote office with a pair of 24-port PoE switches and some APs, a large data center with hundreds of switches, or in a variety of public cloud environments, whether it's Azure, AWS, or GCP, it's the same exact approach. Everything that we're going to talk about today really wouldn't be possible without the right software foundation. Now, if you take a look at this comparison, you don't need to know anything about software architecture or technology at all. It's easy to determine which model is more complicated and prone to failure. If you take a look at the model on the left, you have this monolithic architecture with a lot of interdependencies. So for example, if you have an issue with your spanning tree agent, the likelihood of a major system impact is very high. That, coupled with custom ASICs, makes this model overly complicated and difficult to scale. Now, if you take a look at the model on the right, which is what EOS looks like under the hood, you have a very different approach. And this is how we've been shipping our products since day one. You have a publish-subscribe model where sysdb in the center holds the state of all of the software agents. So there's no direct interdependencies. So back to my original example, if you have an issue with your spanning tree agent, in fact, you can actually jump into Bash and kill that particular Linux process or other software agent that's of interest, and the other software agents receive the last known state from sysdb, and everything just keeps humming along. This model provides the highest level of resiliency that networks should have today. All Arista solutions are built on unmodified Linux and leverage merchant silicon to give you the simplest, scalable model with the highest level of quality. Now shifting gears over to CloudVision Portal. This is a great summation of what CloudVision Portal actually is, which will be the primary focus of the remainder of today's session. CloudVision really wouldn't be made possible or as powerful as it is without EOS, which I just reviewed on the previous slide. Since Arista is able to provide that single binary operating system across the board, you literally have one place to capture all the real-time state of every EOS device in that single pane of glass. You don't need a separate tool and separate operational model for your campus, for your data center, for your public cloud. It's one operating system and one pane of glass to manage your entire environment. From a deployment perspective, all EOS devices are in zero-touch provisioning mode by default, so you can operate in a model where you don't need to console to a device ever to provision it. CloudVision Portal could be your zero-touch provisioning server, and all you need to do is add option 67 to your DHCP scope. And when the Arista device boots up, it will send out a DHCP request on any up and connected interface and automatically appear in CloudVision for you to provision. We have the same approach on the RMA side. You can literally right-click a device that's in question in CloudVision's provisioning view, click on Replace, and then select that device that's been newly zero-touch provisioned to streamline the RMA process, because that device will then be provisioned to the last known good state from both a config and image perspective. Now, taking a look at the change control process, I think about some of the things I would do from a manual perspective pre and post change when I was on the customer side. Arista completely automates that workflow with the change management application in CloudVision. You can create custom snapshots for your environment that allow you to take an automated capture of the state of the network both pre and post change. Roll back a network change with a simple click of a button, whether you made a config, an image upgrade. I won't steal Joe's thunder for later on, where he'll show you this live in action. Joe will also show you the compliance dashboard. I have customers that pay a significant amount of professional services dollars to their vendors for bug scrubs, which is completely unnecessary. Arista not only provides a single binary operating system, but we take it a step further and automate the bug scrub process completely, which Joe will showcase to you as well. From a day 2 operational perspective, the real-time telemetry that you get out of CloudVision is where CloudVision really shines. Most customers still use SNMP for monitoring, which Arista supports, but as you all know, the problem with SNMP polling is you can only go so low in terms of the polling interval. With Arista's approach, you literally receive any sysdb state change that's observed on an EOS device in real time, which ultimately gives you sub-second alerting and true real-time telemetry. So now you can move into more of a proactive approach versus reactive operational model. Also, with real-time telemetry provided from CloudVision, you're able to provide cognitive analytics to that data to provide things like anomaly detection and predictive analytics versus the common SNMP trap that tells you a link went down that after a while just becomes noise. The other thing you'll continue to see with Arista is we don't veer off and try to do everything in your environment. We stay focused and execute on what we do really well, and with our open software approach and APIs, we enable you to have a best-of-breed network where you can pick your own virtualization, your own security, or any other service vendor you need to interact with the network, and we enable that to work really well. Now, taking a look at public cloud deployments in particular, one of the challenges from an operational perspective is each cloud provider has its own offering in terms of service monitoring, which Arista integrates with. But what happens when you have multiple cloud providers that you're deployed in for cloud diversification? CloudVision addresses that challenge in a few different ways, one of which is the multi-cloud dashboard that was covered in session 1, which provides key metrics of importance so you're able to look across multiple cloud providers and understand powerful metrics information. Another powerful application in CloudVision from a monitoring perspective is CloudTracer. CloudTracer was introduced as part of our hybrid cloud solution because of Arista's single binary operating system. You can leverage this application for any EOS device, virtual or physical. Under the covers, the way this works is on the EOS devices themselves, you configure target endpoints where you want to capture certain metrics on. So for example, if you could have google.com as a target endpoint, and then these metrics are streamed back from the EOS device to CloudVision, such as HTTP response time, jitter, latency, and packet loss. So aside from just a ping and trace route, to the different cloud providers, you're really able to understand some really powerful metrics to understand your overall network health. Now let's take a look at this live. As you can see, I have a handful of devices here on the left. And these devices automatically populate in CloudVision's CloudTracer application when CloudTracer is configured on the devices as well, the devices themselves. So you have a list of the devices here, and then you actually have the target endpoints. So if I select a couple of these devices and the target endpoints are automatically selected, you can then navigate through the different metrics. So for example here, you have HTTP response time, or jitter, or latency, or packet loss. And keep in mind, this is all live. You can go back in time to look at, maybe another day and another month. But the whole beauty of this is it's in real time. You can actually take a look at the latency metric or any other metric in particular, and then drill into that metric for that certain target point and get powerful things like metric history, statistics, things like that, that really help with traffic patterns and really understanding what's going on in your environment. CloudTracer is a prime example of how you can standardize your operational model. Not only does this support CloudEOS for multi-cloud, but you can have CloudEOS deployed on-prem, as many of my customers do for various environments. For example, you can leverage CloudTracer on your wide area network, which is a really great use case where you can monitor your point-to-point links between devices. How cool would it be to see latency, packet loss, HTTP response time across your wide area network in real time, and then have that same level of visibility across your direct connect or your express route links? Another key aspect of the operational challenge that's presented when multiple cloud providers are leveraged is provisioning. During session 1, Fran and Fan walked you through CloudVision's Terraform tie-in, which enables you to easily deploy as well as tear down cloud services in a nice automated fashion. But once you have your deployments initially completed, maybe they're going to be in place for a production workflow. What happens about day 2 in terms of provisioning? CloudVision's provisioning application makes day 2 and beyond provisioning clean, consistent, and easy to leverage. Here's a snapshot of what our provisioning view looks like, but what I want to do is walk you through live and show you some good examples of how powerful our provisioning view is. Now this is CloudVision Portal, and this is our network provisioning view. Now this is not a topology view. Joe's actually going to walk you through our real-time topology view shortly, but this is a way of organizing your devices into containers. And it's flexible enough that you can organize the devices in whatever way makes sense for your environment. For example, you could have a data center container or a user closet container or a DMF container or an Azure, AWS, GCP container. Whatever makes sense for you, you can set CloudVision up in that way. And this is a hierarchical model where you can apply the most common attributes to the highest point in the hierarchy to streamline config and/or image changes. So for example, if you have a mandate from a compliance perspective to change the local user credentials across all of your environment once a year, maybe more often than that. If you had to do that leveraging a box-by-box approach, you increase the likelihood of human error, and it's just time-consuming and really not worthwhile. You can automate the entire process and then apply that attribute to the highest level of the hierarchy here, which would be the tenant level. So you would apply that configuration file, or configlet as we call them in CloudVision, to the tenant level, and then when you need to update the user credentials, you're doing it at just the configlet. And CloudVision's smart enough to know that all devices, containers and devices beneath the tenant level need to be updated. And I'll show you an example of that here. So if I go over to my configlets, you have a list of configlets here. Let me look for my local username. I have a configlet here called username. It's not applied to any containers or devices. It was created by the username that I logged in with, and it tells you exactly when it was created. So from an auditing perspective, there's no mystery in terms of how things got where they are. Now let me just edit this here, show you an example. So let me just say username NetBuilders one of the cool little things on our configlet organization is the ability to validate your syntax. Because a lot of times what my customers do is they'll have configlets with multiple lines of config that they may stage to execute at 3 o'clock in the morning the next day, or a week from now, or whatever the case may be. But how do you make sure your syntax is right? You can actually validate your syntax against the device or group of devices that you're proposing it against, and it will actually tell you, hey, on line 1 you have an error here, obviously because I spelled secret incorrectly. So I can just change that, and I can do the same thing here, and I can validate that. And now it's been successfully validated. So I'm going to save that. And now if I take a look at Leaf 1, I want to see what user accounts are configured on this box. So I've got 4 users: admin, Arista, CVP admin, and EC2 user. So the username NetBuilders does not exist here yet. If I go back to my provisioning view, what I want to do is assign that configlet to my Leaf container. So I'm just going to do a simple search here again for username. I'm going to select that, and you can pop it open to see exactly what the configlet contains. I'm going to click Update and then Save. Now this does not push the change to the devices, but instead stages them. So you can see there's actually a T assigned to the container and the devices themselves to represent a task has been generated. So I'm going to go to my tasks. I have 4 pending tasks here. I'm going to select them all and go into my change control workflow. Now, the change control workflow completely automates the change control process, which Joe's going to take you through. I don't want to steal his thunder whatsoever. So what I'm going to do is just do a simple review and approve, and I'm going to execute these. You can actually see exactly what I'm doing. Again, not to steal Joe's thunder, but you can see there's a +1 here, a new line of config, obviously for that username, and it's across, you can see exactly what devices, and then you can approve it and then execute it. And you have a nice little status bar here across all the devices to see exactly when the change is completed, as well as logging. So for example, if you had a syntax error, maybe you didn't validate your configlet, that change is probably going to fail, and you can see in the log exactly why a change failed. So if I go back to my device now, I can see username NetBuilders has been added. And this is a very, very simple example, but think about the power of this and making changes to multiple devices. Now, every single device in the Leaf container, the username NetBuilders configuration is identical, cookie cutter across the entire environment. Another aspect of this is, let's say I pushed this change, even though this was just a username change. Maybe it was a BGP routing update, and it created some significant downtime or issues in my network, and I need to roll that back. Now, what if you need to roll that back across 10 devices, 50 devices, maybe even more? Doing that from a box-by-box approach can create a lot of complexity and stress. So you can just roll that back with a couple clicks. It's going to tell you exactly what I'm rolling back here. I can approve it and execute it. And again, just a very brief example here, so not going to take a ton of time to roll this back, but you can see a status. And then what I can do is go right back here and see now I'm back to my original 4 users. Now, as I said before, this is a very simple example of how powerful provisioning can be from CloudVision, and you can leverage the same approach to standardize your operational model across anywhere you have an Arista device configured, whether it's in AWS, Azure, GCP, or in your primary private cloud data centers on-prem. With that, I'm going to hand it off to Joe Yohannan to explore CloudVision's topology view. Joe?
Thanks, Tom. Good stuff. My name is Joe Yohannan, and I'm one of the systems engineers here at Arista. and like to take a little bit and share with you a feature on CloudVision called Topology View. And here I'm in CloudVision now, and if I just click on the topology, it'll give you a view of our entire network. This session we're focusing mostly on on the cloud implementations, so that's what I'm going to get into. That's what we have right up here. I can zoom in, take a look at our VPC routing resources, and then our edge devices. But Topology View supports more than just the cloud. We have our data centers, we have our campuses, and that's what we're illustrating down here. So if I zoom in here, and this is one of my data centers, I can click on devices, find out links, connectivity, all sorts of information. I can bring it in, and then I can expand other places. Let's go down to the campus here. So here we're in a campus, headquarters, IDF, per floor. I'll double click on that to expand it. So we find our campus switch, we find access points, phones connected, and this topology view is built using LLDP. So even more than just Arista, also third-party devices that are connected and running LLDP, we can show you where they're connected, information about them. So it's a wealth of information. What do we have up here? So here's another data center. I can expand. We have rack 3. I'll expand it. Check. We got 2 top of racks, probably MLAG peers, a bunch of servers. I can click on a server, find out whatever information I can get via LLDP. So that's just the overall on topology view, but I wanted to focus on the cloud implementation. Right now, let me close this up. Okay, so that's Azure West, and then we have Azure East. So 2 different setups here, and I'll double click on it to expand it. I can click on any device to find out information about it, as well as what neighbors. So this is one of the VPC resource Cloud EOS implementations. This that I'm using is a lab, so that's why it's listed as a VEOS, but it's basically showing the cloud implementation. So that would only be connected to the 2 edge devices, but if I click on one of the edge devices, we'll see connectivity to all of the edge devices, as well as down and bringing it back into our data centers. And then I can quickly find out about the health of the network. And how I would do that is just by going over to our link overlay information, and I can choose what I'd like to highlight. So if I choose bandwidth utilization, I'll get a nice color chart here, and it'll show me where are the busy links. And this is valuable, of course, to find out do we have a network hotspot, and is there something that we need to do about it? Is there any drops, etc., that I need to address? But drops, I could actually take a look at something else, like discard rate, for instance. So we're not no discards in cloud, but if I zoom out, in our data center we do have some, so that might be something we want to address. I can highlight it and find out more about it. I guess I gotta zoom in a bit more there. There you go. But that was bandwidth utilization, discards. There's a lot of information we can find here. Traffic throughput. So throughput would include what the interface speed is. So you might have a 1 gig link that's highly utilized and a 100 gig link that's not. But the metrics are different and used differently, but just as interesting, with the same color code and including our cloud setup. So we're in Azure West, and then I can check if I have other cloud implementations. I can double click on that. I'll double click on that and zoom in. Now I can look at each VPC resource, each edge device. Here we have the neighbors. And then I'll go back to the overlays and find out information about that. There we are. And another cool thing with the link overlays that I always like to share is we can show you where VNIs are throughout your network. So if you have a VXLAN VNI that is just in the data center, that's fine. But if you have other ones that are throughout your organization, for whatever reason, the data center, the campus, your cloud implementation, we can click on that and actually map out where our VNIs are. So if I highlight this link in my data center, VNI 5, what do we have here? VNI 100. So I can just go ahead and map out or take a look on each link. Where are the, this, what's on this link, which VNIs? So that's pretty cool. And like I said, that extends to all parts of the network. Here we're back in the campus. We'll zoom back out. And just by highlighting the link, we can find out which VNIs are on there. And then same thing with VLANs. There we are. So just VLAN 1 there, VLAN 3, VLAN 1 and 3. So some trunk links, VLANs 3 and 4. So good stuff. So that's what I wanted to share here. And then we're going to just move on over to the next topic. All right. And from topology, I wanted to take a moment to show you the compliance dashboard. Over at Devices, Compliance Overview. So this is a screen that I picture can be used in a network operations environment. If you have some screens to be aware of the current situation, this could be used there. Or depending on what your operational workflow is, if you want to check it every morning, whatever works for what you're looking for. But the compliance overview gives us a summarized view of any bugs that we might be at risk for, any security advisories that have been released and we have not addressed with a security patch or an updated version of EOS that takes care of that vulnerability, and also your configuration. So if you're managing your network with CloudVision, you're making your configuration changes through CloudVision. So CloudVision is always aware of what the compliant configuration is with each device that's being managed. Now, when you are managing your devices with CloudVision, whether they're the cloud nodes or a physical node or what have you, you're not locked out of the CLI. So you still, as long as you have it configured, you have SSH access, and if it's a hot moment and you're troubleshooting and you need to make a change, then you could do, config space T, make your change. And so that tool is not taken away from you. However, if you do that, then obviously CloudVision is going to feel that node is out of compliance, and it'll notify you. It'll proactively notify you, which is a good thing. And now you would have the ability to accept that new change as the compliant configuration, of course, or you can revert back, depending. I'm from the customer side prior to Arista, and I often talk about how many times I'm in a situation where I have to fix something fast, and I'm on the command line, and I make change number 1, it doesn't fix the problem. I make change number 2, it does fix the problem, and I never back out change number 1, and the next day I got hit by it. So at least when you have something like this, that's much less likely to occur. So that's a good thing. Also, with CloudVision, the ability of CloudVision to reach out to Arista.com and download the current bug database and any of the security advisories in whatever frequency you would like, you're being proactively notified. So it's not that there's an issue going on and you have to open up a attack case and there was user application, difficulties, and people are calling the help desk, you would be aware of it proactively. So you can take a look at the bug, and is it cosmetic? Is it a big deal, or is it a P1 bug? Is it something that's at risk? And you're enabled to take an action prior to, hopefully prior to any users having any issues. So you could just click on like device configuration, for instance, and see if anything's out of config. And this is current, by the way. So this is the live version. I can click on live and move it and check how was it earlier. So we have the historical view of all of telemetry and compliance in CloudVision. And then if I want to check a different day, I can choose a different day and choose apply. And that was the situation yesterday. If I want to go back to live, I'll just click back on live. So this is a nice, simple little tool that makes a huge difference as far as, what type of risk are you, exposed to in your environment. And, to make sure that all the devices are compliant as for your configuration, for your software image. If you have QA, 4.23.1F or whatever you're using, then that should be the image that's in production. And if some engineer decided to use something different without it going through QA, then we're going to be aware of that and can take action if necessary. Also, in addition to your software image, do you have any extensions that you put on your boxes, or is there any security patches that need to be installed on every box, and is anyone missing? This is where you would be proactively notified of that. So good stuff. It's very easy to set up. Let me see. I have a slide over here. Oh, if you wanted to view the file, it's right under Profile, under Software Download, under CloudVision, and there's this alert-based CVP. It's in JSON format. I don't think you'll enjoy reading it. If you want something that's legible to easy to read, then I recommend the release notes for that version rather than that file. But it works perfectly, obviously, for this functionality. And then I'm in my profile on Arista.com. So Arista, my profile, and I have this token here. So this is the token that I would use. And for any user, whatever customer account that your user is associated with, then you inherit all the entitlements of that account. So if you're a CloudVision customer, then you would have this, and you would just copy it and then go over to CloudVision, configure it in compliance, authentication token, and then you'll start downloading, and you can view to make sure that it's successfully downloaded. And then you will see, where is it? In your screen, and then it'll start populating. So obviously we want this all to be green, but if it's not, then it's something that we need to take a look at, and we're finding out proactively from CloudVision rather than the help desk phone ringing. So good stuff. So thanks for that, and then we'll move on to the next topic.
All right, moving forward, we're going to take a look at change control on CloudVision. So pushing changes via CloudVision. What I have here to show you is our demo cloud. It consists of a couple spines and 4 leaves. They're all virtual EOS nodes, so it's a virtual lab. The beauty of the multi-cloud and cloud EOS solution is that it's the same network stack as any device that you have in your data center or in your campus. It's the same syntax. It's very easy to manage. You have a single pane of glass with CloudVision for troubleshooting visibility that we've gone through. So, whether I'm using virtual EOS, something in my private cloud, which would be my data center, or a public cloud, and whichever one it's all going to be EOS. So it's the same network stack. It's nice and simple and consistent. What we're going to look at is change control. So we're going to be putting in a configuration changes and watch the the tool and how it works. I also have I'm on the command line for Leaf 1 just so we can just bounce back and forth and take a look. Let me see, what we're going to do is we're going to go to provisioning, and what we're looking at here is a configuration hierarchy. So this isn't the topology view that we looked at before. Topology view is the connectivity based off LLDP. What network provisioning hierarchy is the ability to group devices based on their configuration. So I can make changes to, here I have set leaf devices with all 4 leaves under in that container, and then spine, there's a couple over here with spine, if I zoom out. But you could set these up the way you want. If you wanted to send them, I don't know, 7500Rs and 7050Xs, or based on model or whatever you'd like, is it's your choice on how you'd like to do it. But if I wanted to make a change and I want to push it to all 4 leaves, I don't want to SSH to every single one of them and config space T and put the change in. I might forget one. I might make a typo. I just want a quick way to send it to all the devices, and if I wanted to back it out, I could also back it out real easy. So if I make a change here, that means anything under it in that container is going to inherit that configuration. If I made a change here, all of these, everything under it would inherit that config. So the config would be pushed to every single device. So to make a change here, I'm going to do manage configlet. What we'll do is we'll create a configlet. So it's just something simple. Configlet. Let's call it VLAN 50. We'll just add a VLAN configuration for that configlet, and then name, call it test VLAN 50, and then whoops, save. Okay, and so now we have a new configlet. This is a list of configlets, and we can pick and choose what we want for different devices. If I go over to change control, these are change controls that were already executed. I want to create a new one. Whoops, I forgot to create the tasks. Let's go over here. So we created that configlet, but we never applied it to this container. Manage configlets. So we're just gonna, this is by alphabetical order. All right, so VLAN 50 is what we called it. Update. So you'll see the devices. This is the container name, and then the actual devices that this task will be scheduled for are highlighted. I'll click Save, and now they all have a T, which means that there's a task pending. This is important in that if there's more than one engineer that are making changes, if I'm going to design a change that I'm going to put in that night in my change window, and I go to do it and the devices that I'm going to make changes on have a T on it, then that's something that I want to look into, because that means there's already a task that's in queue that's going to go out to these devices, and is my change going to conflict with that? But we just created the tasks. Now I can create my change control, create change control, and then all of the available tasks that are pending are available. All 4 of these are ours because we just made them, but in real life it could be many others. Create change control. And then we also have an operational workflow interop with third parties such as ServiceNow, where when you create the change control, it can kick off a ticket and await approval in ServiceNow, for instance, before we're even able to run it. So that's something that some customers take advantage of. Okay, so here it is. We can set these up to be parallel changes, which means the changes would happen in parallel, and then or we can make them serial, where we can do one or the other. So, say we had 1 and 2 as nlag pair, and 3 and 4 as an nlag pair, and we wanted to do peer A first and then peer B second. So now we're going to do 1 and 3 first and 2 and 4 afterward. So this is our change control. We can add steps if we wanted to do like before and after snapshots of what the what's going on with the devices before and after, and what's the changes during our change. That's something that we could do. Just to keep this short, we're gonna just go with the actual configuration change. So this is it, VLAN 50 named test VLAN 50. Let's take a look at the command line, show VLAN. So there's no VLAN 50. And I checked on the command line. If I wanted to, we can, in CloudVision, we could just see, what configlets are applied to that device, and it would be basically the exact same thing. So let's go ahead and approve this. And now we're in position to run it during our change window. For the purposes of this example, our change window is now. So I'll go ahead and execute. And we can watch the progress as we go. Should be fairly quick. So leafs 1 and 3 are complete. Now it moves on to leafs 2 and 4. And while we're waiting for that, we can take a look at the command line here. And there it is. So VLAN 50 test VLAN 50. So our configurations were applied. Okay, and we can roll back the change with a hit of a button. So that's pretty cool. Let's go ahead and take a look at which configulators are applied to the leaf container, which is basically the same thing that we already did on the command line when we did show VLAN. But these are all the configulators that are available in CloudVision, and we can pick and choose whatever ones we want to apply to a device or to a container, which is instead of picking one that was already created, we created a new one, VLAN 50, and we see it checked off here. So we're looking at the leaf container, and anything with a blue check means that's applied to that container. So every device that's within that container has that configuration. And if I wanted to edit the config, I could just edit it, save it, create a change control, and push it. And basically we did the same thing. We just updated a configlet rather than creating one. But good stuff. So this is what you would do if you had, say, CloudEOS Edge devices or CloudEOS Leaf devices, and you had them in multiple different cloud providers, and you wanted to make a configuration change that applied to them all. That's how easy it is. You would just choose all those devices, create the task, and then create the change control, and then execute it. And all of those devices would reflect that change. And CloudVision also tracks what the configuration is for all those devices. So if for any reason, if it's not able to get to the node or what have you, that the change didn't go in, then you're going to be proactively notified that you have a device that's out of compliance. And CloudVision won't make an automated change without your knowledge. But you would be prompted to take an action, which would be probably to find out the reason why that node was not available, and then make sure it has the config. But it would be up to you and up to the situation. But that's it for today. So we made it through the NetBuilders webinar. On behalf of Tom and I and Arista, I'd like to thank you for your time. It's been a pleasure going over this, and it's something that I enjoy talking about. So, if you have any questions, you have a local sales team. But my name is Joe Yohannan. My email is joeyo, Joeyo, @arista.com. Feel free to reach out. So, in any case, enjoy the rest of your day, and thanks again for your time. Thank you, guys.